Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 1 of the SQL Injection module. So let's look at the description. This lab contains a SQL injection vulnerability in the product category filter. So that's important to SQL injection vulnerability, and it's in the product category filter. When the user selects a category, the application carries out the SQL query like the following, so it actually gives us the backend SQL query that gets executed. Which is great because we know the structure of the query. That means we know how to automatically build our SQL payload, and we'll see that in a bit. And then to solve the lab, perform a SQL injection attack that causes the application to display details of all products in any category, both released and unreleased. So the end goal is to display all products, regardless of their category, are both released and unreleased. So what's likely happening is that the application displays the released products to the user. However, there are unreleased products that are not displayed to the public, and what we're going to try to do is exploit the SQL injection vulnerability and display the unreleased products. So let's click on the link over here. It's a shopping application, and you could refine what you see depending on category. So there is 12,340,1,230 3 times 4, so 12 products that you could buy. However, if you refine your search to, for example, just spots, it'll display 3 products, which are somehow related to paths. And if you look at the URL over here, you'll see that the category that you selected gets populated in a parameter in the URL called category. So this is the category filter that has a SQL injection vulnerability. So this is the one that we need to exploit. Now what's happening over here? Let's have an analysis section. When you entered paths, what's happening is it puts in the category field and it runs this query. And what this query does is it says select all the rows from the products table where the category column is equal to paths and the release column is equal to 1. So what it'll show you is all the products that are in the category pets, but also they have to be products that have been released. So if released was equal to, for example, 0, then you wouldn't see product over here because it's not released to the public. So now, let's try a common SQL character that if the application doesn't properly validate user input and doesn't use parameterized queries, then chances are it is vulnerable to SQL injection. A way to detect that is to add SQL characters that might break the query. And one of the most used ones is the quote character or the double quote character. So let's try that and see what happens. Okay, so we get an internal server. So right away, I'm thinking this is vulnerable to a SQL injection, and the reason I think that way is because what's happening at the back end is this. Instead of having pets over here, we entered a single quote, and so I broke the application because the way it sees it is select all the rows from the products table where the category field is equal to nothing. So this quote over here that we added closed the other quote for the category field, and then all of a sudden it has a single quote that likely resulted in a syntax error, which resulted in an error in the web server and internal server error in the web server error. And so we broke the application. So this is an indication that it's vulnerable to SQL injection. We don't know yet that it is. So let's try to build a SQL injection payload to confirm our suspicions. And to do that, I need the application to respond properly instead of responding with an error. So what I'm going to do is this quote over here that I added. It closes this quote over here. And so I'm going to add the comment field in order to tell it to ignore the rest of the query. And this way it won't run into this single quote and it won't generate an error. So let's put that payload over here. And before I run it, what needs? What would happen at the back end right now is it'll literally just run this query over here. So select all rows from the products table where the category is equal to nothing. And then because this is a comment field, that will ignore the rest of the query, and this is a valid query, so it shouldn't give me an error. Let's run it, and here we go. So we don't get an error. We also don't get an error. We also don't get an error search results because the category field is set to nothing. So it works. Now I'm confident that it is vulnerable to SQL injection vulnerability, and so the next thing to do is to try to solve the exercise. So we said the end goal of the exercise is to display all the products, both released and unreleased. Oh, let's copy our query again and try to solve this exercise. Okay, so I needed to display all the products, so I'm going to add an or 1 is equal to 1. So a conditional statement. So what this will do is it'll say select all the rows from the products table where category is equal to where either category is equal to nothing, or the conditional statement 1 is equal to 1 evaluates to 2. Now 1 is equal to 1 will always evaluate to true, and so it will display all the rows and the products table. So let's try that out. This is our query over here. Sorry, our SQL injection payload, and hit enter. And here we go. It says, congratulations, you've solved the lab. Make sure to hit the subscribe and share button so that the video reaches a wider audience. Thank you, and see you in the next video.